And we're live. Good evening, everybody, especially to my Marlborough students who are either watching this or in the Hangout. This is our Hour of Code Week all around the world, and we are participating in Vermont in all kinds of ways, including having these virtual guest speakers. This one was scheduled for my class Create with Code at the Grad Center at Marlborough College. And I'm Lucy DeLabriere, by the way, and I am a Google certified teacher and trainer and Raspberry Pi instructor, and mostly I have 30 years of experience in the classroom, and a lot of it was learning to code with my students. So I'm really excited about the class we're teaching, my student projects, and I'm super excited that tonight we have Sam Patterson with us, who I got to meet in Mountain View when I at Raspberry Pi Academy, and also got a tour of his classroom, which the minute I walked in, I knew that this was like an amazing teacher. And the more I've gotten to know him and follow him on Twitter and reading his book about programming with younger learners, we're certainly kindred spirits. And I'm so glad that he agreed to speak to us tonight on programming with early learners. Welcome, Sam.
Thank you so much. What a great introduction. I'm honored to be here. And yeah, it was almost a year ago that we were in Mountain View together at the Raspberry Pi Academy. And that was such a phenomenal experience of professional development because we spent so much time doing things, right? There were like 6 main workshops and you had to do this thing, do that thing, and it was all very hands-on. And that was a lot of fun. But one of the best parts was that we all got to go over to my makerspace and classroom in between the 2 days and build some pieces that we could use the next day in the hackathon, which it was such an experience. I'm honored to be here sharing with your students and anyone else about Hour of Code because as an elementary tech teacher and a makerspace teacher, I have found programming and coding to be one of these transformational tools that I can bring into the classroom. Now, you were saying how you've had years of experience teaching kids to code. I'm still actually pretty new to code. It was 4 years ago. I was a high school English teacher, and I made the jump to elementary tech, and I had to learn something about programming really fast. And one of the first things I learned about programming this was a lesson I learned with kindergartners. The lesson was that their logic can exceed your expectations. Now, sometimes it won't because there's actual brain chemistry like prefrontal cortex hasn't formed yet, et cetera, et cetera. But I'm sitting there working with a kindergartner and she cannot read. And we're working in Codable. And there's a level called functions where you essentially take an empty function and you assign 3 moves to it. For example, up, right, up. And then every time in that maze you want to go up, right, and up, instead of putting in up, right, and up, you put in your function block. When you go to the next screen, you have to redefine that function block. So it works as a user-defined variable. Quick side note, I was an English teacher, but I've always taught in independent schools. So I've also taught math. I taught algebra for a couple of years. I taught 6th graders algebra. Variables make them cry. Make them cry, right? Like I even had a 9th grader one year who was still working on algebra, and I remember just her tears of anger about variables and the way they worked and how they made no sense. This kindergarten, after I describe how this works, I ask her a couple questions to clarify, and she's like, oh, well, it means this on this screen because I made it mean this, and on the next screen it'll mean whatever I make it mean there. And I was just like, oh my goodness, this child just explained what used to make my 6th grade students cry. So when you're working with little kids and computer programming, try more than you think they can be successful with, right? You put it out there and you build an environment of trying things out and testing it out and seeing if it works. And when they're successful, you celebrate with them. And you know when they're successful because you've got fist pumps, right? Like what I love about working with little kids is when they're coding, there's fist pumps and there's tears. And you can tell, from across the room how well it's going. So as a quick introduction, yeah, my main, like, one thing with programming with the littles is check your expectations and give them opportunities to do amazing stuff. Welcome, Cynthia. So glad you joined us.
Hi, hello. Oh, sorry, I'm going to try and keep noise to a minimum since I'm at home.
Hello, Cynthia's dogs.
Yes, thank you.
That moment when I was working with my kindergarten students and I had this student who couldn't read explain to me how variables work, I had this thought. I said to myself, if I can get my pre-reading students to program, can I use programming to help them become better readers? Now, a little background, I have a doctorate in literacy education. I got this degree working as an English teacher, specifically looking for ways to help make response to student writing more effective so that my students were more empowered as writers. I have always enjoyed running a creative writing classroom that was really focused on self-expression. I taught all the other stuff that went along with teaching English because that was the only place where we get to teach writing. Now, as a makerspace teacher, I find myself, I'm coming back all the time to these literacy-rich activities. It turns out that sequencing, when you take a complex activity and you break it up into a number of steps, and then you express those steps with code, that sequencing helps students become better, more ready to read. So when you take a pre-reading student and you have them work with the Foos, or with the Kibo robot, or with Bbots, or with Codable, or with any of the other tools out there, that act by itself is actually helping them get more ready to read. And that was pretty exciting to me, but it wasn't really enough. So then I'm wondering, how can I use these different programming interfaces to get kids to do more of the stuff we know helps them become ready to read? So that's when I started looking at these different programming opportunities and asking, how does this fit into what we know about good teaching? Like, what does a good learning experience that uses a Bbot look like? What does a good learning experience that uses Scratch Junior look like? With Hour of Code, it's really an amazing opportunity, but there are two different experiences you can have in Hour of Code. You can have a closed experience or an open experience. Now, the closed experiences are things like the Plants vs. Zombies game, right? Where there's 25 levels and all of the challenges are pre-written. Do this, do this, do this, and they're assessed immediately. You were successful or you weren't. The more open-ended experiences are ones like the Scratch tutorials where they say make it fly, and you're walked through a tutorial on how to work Scratch, but there's all of the tools are available there, and you can essentially go off script at any moment. Both of these activities have a place in the classroom when it comes to instructional design with coding. Yet played with Scratch Junior. That is one of the highest return tools for anybody new to coding, especially with the younger kids. And what's really exciting is as Scratch is growing, the new version of Scratch that they're calling Scratch 3.0 is actually going to look a lot like Scratch Junior, where they're going to use more of a horizontal programming interface that is less language dependent and not rely so much on the vertical text structured drag and drop that Scratch really features now, because they're looking to get out of an English dominated platform, which is very exciting for those of us who work with pre-readers. So even if you're using Scratch Junior to create your own closed lesson, imagine this. What you can do, let's say you're working with first graders and they are learning spelling, and we've got the words are, there, were, and here. Those 4 words use about 7 different letters, right? There's a bunch of E's, H, R, A, W, yeah. So I take those letters and I make each one of them a character in Scratch Junior, and I put them on the top of the screen. And I can do that by hitting Create New Character, hit the blank space, hit the paintbrush, draw the letter E, Click done, it imports it with a transparent background. Now, if you've ever given your students a word letter worksheet where they have a number of words and they have to take one word, unscramble the letters, put them in the right order, and then in the next step they have to change one of the letters to make a different word, we can do all of that with programming. So we're going to take the mixed letters up here, we're going to program them each individually to come down into the right spot. We're going to do this by hitting the math button. There's a grid button on Scratch Junior that I call the Common Core math button because as soon as you hit it, the kids start saying, oh, I'm on spot 4 and I need to get to spot 13. What's the distance between 4 and 13? How many spots do I have to move to go from 4 to 13? There's like, oh, it's just applied math over and over and over and over again. And keep in mind, I'm looking to hit literacy standards, right? So I'm just pinging off the math standards all along the way as I'm working my way towards my literacy standards. You ask the students to take a word and spell it on the line. And they're like, okay, I'm done. All right, now take one of those letters, make it go away, have another letter come down and make a different word. And then they have a fairly complex programming problem that they're working through. The whole time they're rehearsing spelling because they're like, okay, this is here, this is here, this is here. We're going to turn it into where by bringing down the W. Here it turns into where by bringing down the W. You're just repeating this time and time and time again. So you've taken your word ladder activity. You've added a level of explicit sequencing that is good for vocabulary or good for literacy development. And you've added a level of cognitive complexity where this activity becomes iterative and they end up going from one word into another, into another. Many of my students just completed the first word, but the more advanced programmers, they had 3 words chained in a ladder and they figured out the weight blocks to actually do it. It was amazing. And that was what I would consider a closed activity. Is it the highest use of Scratch Junior? No. Is it a lifesaver for teachers who are like bored to tears of the handouts they're given? Yes. We can take any of these handouts and recreate it in that Scratch Junior environment. I'm going to talk really quickly about the mechanics of that. Scratch Junior can be a little tricky to share with, but there is an AirDrop button and there is an email button. So if you're using it in like a Chromebook environment, you should be able to email the program to your students. I'm using it in an iPad environment so I can AirDrop them. I think with the Androids, you can use their near field to send a program from one device to another, but that does get a little tricky because you have to build the program on your device and then export it to theirs. So the first time you do that, give yourself some time for that. When they finish, if you want to collect their work, you have to run that process in reverse. So my first grade students knew at the end of a Scratch Junior lesson, they would form a little line and come up and AirDrop it with me. And once they knew how that worked, they could do it largely independently. I tried to do it on cue. Otherwise, my iPad would always have these AirDrops coming in. And I'm like, wait. Let's do this now. And then I could click accept on all of them and they could bring it in. I can put those into a Google Drive folder. I can put that Google Drive folder on my website or email the link to my parents. And I can say, if you want to open your kid's file in Scratch Junior, you can get to it this way. It's not the most shareable format. It's a little frustrating with that, but it is safe. And so they're working to make it COPA compliant and keep it internet safe. But at the same time, give the kids all those amazing tools for just sharing things. Now, the other thing I want to mention really briefly with Scratch Junior is that we used it last year with first grade with Writer's Workshop. And if you write stories with your kids in first grade and you have them do a storyboard, if you take that storyboard template and scrunch it down to 4 panels, because right now you can only make 4 different scenes in Scratch Junior, it works as a great pre-writing exercise for the programming. If you want your students to be successful in programming or movie making, you have to have them plan first. So have your first graders plan out a 4-page story, and then instead of making a booklet or going to a paper book, open up Scratch Junior and have them create the story in there. What I love about doing that is the fact that Scratch Junior allows you to create text bubbles. So you can have speech bubbles of what the characters say. You can also label things in the background. Anything on the screen, you can apply a label to it. And there is an audio record button. Now, the audio record button means that my kids who can't figure out how to spell or write or type something can still tell their story. So what I love about Scratch Junior is it's a tool that bridges the difference between a student's fluency and a student's literacy. So we've been talking about programming, and I've talked a lot about Scratch Junior, and I've talked a lot about the literacy skill development, but we haven't been talking about robots or apps or STEM jobs or any of that. Because really, for the youngest kids, yes, I want all of my girls to know they can program, right? I want all of my kids to feel like empowered creators when they come to a digital device. But it's much more about giving them the tools to tell their story, to express themselves, to say what they want to say, to share what they want to share with the world. And once they have it, it just about disappears. It becomes this thing they can just do. And the teachers I'm working with now, I'm trying to work with them on the concept of Scratch Junior is something you can do for 10 minutes, right? We don't have to dive into it for an hour or an hour and a half at a time, especially if you have regular access to the iPads. It can be something where it's really simple. They also have a photo import. So you can take a picture of your desktop. Imagine you have a worksheet that your students have done 100 million times, and you really like them to explain how they did that math problem, right? You take the worksheet, you put it on the tabletop, you take the laptop, you open up Scratch Junior, you say, I want a custom background, I'm going to use the camera and define it as the background, and you take the picture of the tabletop. And then you have Scratch the Cat walk around the math problem and explain what the different parts are, right? It's really simple. You can even use it as essentially a replacement for Explain Everything. But instead of using real time and the timeline to control things, you're just using the programming tools. And the kids have to think about what they want to have happen first, what they want to have happen second, what they want to have happen third, and they have to plan those things out, and then they have to write the code to make it happen. Well, pause there and find out if there's any questions about that, because I could call that kind of my foundational Y code with littles, and basically because it's such a powerful way to get them to be able to express themselves. So anybody have questions? You're all muted right now. You can unmute yourselves if you don't want to.
I was just going to say,
yeah.
I'm hearing an echo when I talk, but I'm going to mute myself again, and maybe unmute yourself. Welcome, Andrew, if you have questions for Sam while he pauses.
Okay.
Try it again, Cynthia.
I had a small person join me for the talk, and there was talking, so I apologize.
Not at all. So yeah, Scratch Junior, super powerful, and one of the great things is it's free and it's available on any platform. It's developed by the Lifelong Kindergarten Project, and the folks, I believe it is at Rutgers, are the ones that are mainly in charge of it. I got to meet some of that team this summer when I was at MIT for the Scratch Conference, and that was amazing. It's in the US every other year. It was the smallest conference I've ever been to, and everybody there was crazy brilliant. So if I'm lucky enough to be able to go again, I will. And I would say that any of you who like have any interest in programming at all, that is a place to go.
Was Marina there?
Yes.
I walked into a conference one time, an exhibit hall in an innovation area, and I was talking to this woman for about 20 minutes and did not realize I was talking to Marina when she was just showcasing the, what's the little...
Kibo?
Not Kibo, right? And then I looked up, I go, oh my God, she's awesome.
Yeah, there very briefly. I'm trying to remember the UI designer was also there, and she was also brilliant. She was the one who like made the whole look of it. Mm-hmm. And I got to have breakfast with her one morning, which is really just mind-blowing because there's all kinds of people out there making tools, right? Yeah. There's people out there trying to make a living making tools. There's people out there trying to get rich making tools. And then there's the crowd out of MIT Media Lab, right? These are the folks that are making Scratch. They're making Makey, they're making Scratch Junior, they're, you know, helping the Lego Foundation. And I think that it's really worth a teacher's time when they're using these tools to look at who are the people behind the tools I'm bringing into my classroom and what are their educational goals, right? Because even in Hour of Code, you have all kinds of different vendors that are represented in that space. You have retailers like Cano who are focusing on creating kits that kids can build and program with. You have companies like Tinker who are building apps and tutorials and systems of tutorials that they sell to schools. You have groups like Sphero who are trying to sell as many small little robots as possible. And then you've got people like the Scratch Foundation and MIT Media Lab who are really, you know, kind of meeting the challenge of creative self-expression day in, day in, day. If I'm not talking about Scratch Junior, the next thing I love talking about is Scratch. Right? Like teachers who are out there who are doing work with kids for Hour of Code. And even if they have only time to get to one thing, I tell them use one of the Scratch tutorials. Because if your kids can read, they should be doing things in Scratch. Scratch, for a while, I would hear conversations that were like, well, it's not a real programming language, or we want to program with like a genuine language, or that's not, you know, it's not real. And that, I thought, the best counter argument to that I read in the book Invent to Learn by Sylvia Martinez and Gary Steger. And they basically said Scratch is completely brilliant for anything you need to learn. And when you're trying to do something that's too hard to do in Scratch, you're ready for a different language. And I've seen this in my own kids, right? Because Scratch is wonderful. And when they start building like full games in it, it gets unruly. Like the code starts here and it stretches all the way across. It's like 15, 17 inches long that they're shuffling kind of in and out of this window as they're trying to track what they're doing. And that's when you're like, so can I talk to you about Python? And, you know, I don't know a ton about Python, but when they get to that point, they can go onto a site like pythonroom.com and learn what they need to know about Python and transfer the logical understanding of Scratch that they've built to that environment of Python. You're right, Andrew. Scratch is a great way to get, you know, front-end access to coding. And one of the real advantages now to Scratch is that they have teacher accounts set up so that you can associate your students with your account. You can actually build accounts for your students. So it's much easier to see what they're doing. And I was talking to Saskia, who is the outreach manager for the Scratch Foundation this week. And I was talking to her about the power of that community. We, as teachers, want our students to know digital citizenship. We are often charged with teaching digital citizenship. We're challenged to approach digital citizenship from a standpoint that is not punitive, like don't do this, don't do this, don't do this. But if you get all of your kids in a community like the Scratch community, and you teach them how to interact with other users, how to appreciate someone else's work, how to branch from their work, how to share their work, how to give them feedback on their work, how to solicit feedback from other users. Suddenly you're giving them all the tools they need to be an awesome community member online, and you're giving them that experience, and you're doing it inside one of the best communities out there. Because the Scratch community is curated by the folks at MIT, right? They have community moderators that are on there all the time, trying to make sure that it stays upright, it stays safe. And there's awesome instances of those people in the community taking care of their community. I would never sit here and say, if you want to teach kids digital citizenship, use the comments section on YouTube. That would be madness, right? No one keeps their job through that. But I think that there's a great opportunity to do that with the Scratch community. What's Andrew saying here?
And actually, as you read his piece, and we started with code.org and then Scratch for our whole class, and we looked at a lot of different platforms similarly to what you do in your book, like look at different platforms and figure out the difference between puzzle-based coding and open-ended communities. And then we went to physical computing with Makey Makey, and we just kept, then we went to Arduino, but then now they're all doing their own projects on whichever platform works for them and that they want to go deeper with. And Andrews is on Scratch, so that's why he's actually commenting on a lot of your comments.
Yeah, and you know, it's funny because I curate YouTube videos for my kids, right? And the first time I taught Scratch was 4 years ago, and I did it completely wrong. I tried to learn it for about 3 weeks, and I'm like, I'm going to learn ahead of the kids. You can't. It doesn't work because their brains learn faster, right? I would have had to start 8 years ago to learn ahead of the kids, and I still, like, I spent 3 weeks, right? 3 weeks learning ahead, and I've had this whole thing planned out. In 8 minutes, they were asking me questions I had no idea the answer to, right? So there I am. There's still 40-some minutes left of class, and I need a better strategy. And this was with my 4th graders, and it all worked out. But what I ended up saying was, children, the questions you're shouting at the ceiling, I need you to type them into YouTube. Be sure to include in Scratch when you type them in. And this was with 4th graders. We didn't have a filtered YouTube, so it all worked out. But now I try to like find those ahead of time, right? I'm going to find those. I'm going to say, here's a resource page. Here's a 10-year-old explaining how to do this in Scratch. Here's a 30-year-old explaining how to do it. You know, these are the resources you need. But at the same time, like, yeah, we're going to make you watch videos to learn things. We're going to make you read other people's directions to learn things. We're going to talk you through the fact that sometimes people write really bad directions. And then we're going to ask you to write directions to teach other people about the thing that you learned, right? So you put them in the situation where literacy matters. They want to be able to understand that text that's out there. They find problems in that text. And then you're like, this is an opportunity for you because you've discovered this thing. You can now assemble this text. Ultimately, I want my 6th graders to be able to fire off a YouTube video about how to do something. Really important literacy in this day and age. And if I can use coding to get them excited about creating an instructional video, more power to me, right?
Absolutely. I still remember being in that same position you described when a 10-year-old said, so Mr. Labriere, how do I do gravity? I'm like, good question.
9.8 meters per second squared, constant. You know, that's an interesting problem. What we have here, my friend, is a learning opportunity, right? Like, you have to really be willing to shift that. And the challenge with working with the youngest students is so many teachers who work with elementary students did not decide, I want to work with elementary students because I enjoy not knowing what I'm doing, right? But programming with kids requires that you spend some time not knowing what you're doing. The good news is, as a teacher, I've always believed in a student-centered classroom, but I have rarely had the tools to make that possible. So often, what we were doing in class was determined by the book we were using or the photocopies I had time to make. So no matter how student-centered I want to be, those are giant limiters. But if we're doing something like programming, today my 4th graders finished their class with Neopixel hack. Love it. If you haven't done Neopixel hack, it's a Java-based draw program. It's all text-based coding. Really cool though. There are 20-some levels in there. They were all at different levels. Why were they all at different levels? Because it's a self-driven tutorial that self-differentiates. And that is amazing because I don't know how to do that stuff, right? I just know where most of their problems are going to come in because I've watched them do this 2 or 3 times. And I can come in and I can say, when you wrote the word background is actually the word back and the word ground with a G and not round. And they're like, no. Like, all right, let's go ahead and fix that, right? Let's spell these things right. Let's capitalize things right. And they're really starting to pay attention to that syntax, right? And that allows me to sit alongside the student. Suddenly, I'm not in front of them because I can't carry the water of the knowledge needed, right? It's bigger than what I know. I have a poetry degree. Right? I'm doing the best I can, but I am not a computer scientist. They might be someday. but the guys who wrote these tutorials are. What students do is engage in the genuine literacy of trying to figure this out. And I can help them with perseverance. I can help them with resilience. I can help them with problem solving. I can help them with troubleshooting. These are all things that I'm in a perfect position to teach because I'm no longer trying to teach them to code. Right? We're all learning the coding together. And when I take that knowledge authority and I export it to this tutorial and I let the kids experience that tutorial in a genuine way, it's actually amazing because I get so much more relaxed. Because when I'm supposed to understand everything we're doing, it's really stressful because I don't, right?
I definitely had that experience, in my classrooms back when I had K-12 students. But in this class, you get to that point where you question yourself as a teacher because you don't have all the answers. And I got to that point in this class again. When we got to projects, our students, Cynthia and Nicholas and Andrew, and to all kinds of different levels of projects. Nicholas went on his own working on advanced Arduino and some other game-based programs that I had never heard of. Cynthia had interesting experiences with a lily pad. I had a student doing photon.
Wait, Cynthia, did you get it to register? I've got a closet full of lily pads and I can't get the right library to load. I can't even get them to pay. Like, I keep failing so early in that process. Were you ever successful?
I don't know yet.
Okay. Fair enough, right? I've done a little bit work with a Neopixel, which is simpler than a lily pad. It's like essentially it is programmable, but it was much simpler. And that was at a workshop I attended. I don't know if I could go in the next room and be successful with it right now by myself. But the Neopixel, I now have, like, you turn on a little switch and it turns this RGB LED red. And I'm like, woo!
I consider that a success because I chose this project because I was so frustrated with the lily pad that I was not going to let it beat me. And I will consider anything close to getting it coded a success. I don't even care what Lucy thinks at this point.
Actually, would you share your ultimate goal? I think it's a very interesting storyline. Could you share it briefly?
Sure. So we had as a task to do this project, either to create a lesson as a teacher or to think of ourselves as a student working on a project. And so I had this lily pad because I bought my own. I thought it was really nifty and I loved the idea of the e-textiles. And I thought I would do something with it eventually. And so it made sense for me to figure out how to use the darn thing and use this project. And so in thinking like a student, I was thinking about a problem we have at my house. We have a parakeet and nobody ever feeds the parakeet. And I feed the parakeet is really what comes down to. But when you look at the parakeet's dish, you can never tell if it is full or if it's empty, because when he eats, he leaves the empty shells in his bowl. So it always looks full. And so I always have to go over and poke at it and see if it's full or not. And one day I realized that you have to be able to tell by its weight,
right?
If it's full or not. Or how much is left, basically. And I thought, well, I wonder if I can hook up a weight sensor, a pressure sensor, and have a little LED light up if it goes below a certain weight. So then I'm not having to stick my finger in the food dish all the time. I would really like to not think about this process is what it comes down to.
Right. No, that seems like a good problem to address, right?
Right. It seemed like it was going to work out for me. So, and I looked at a couple of different standards. And at the school that I work at, we use next generation science standards, which I think all of Vermont does.
Yeah.
And so there's a couple of 5th grade engineering standards that would work out really well for this project. So trying to think like a 5th grader and come up with some fairly simple coding that would work for this project.
Right. Ultimately, there's the whatever pressure sensor is, right? And the values of the pressure sensor with nothing on it, with the full thing on it, and you have to figure out where your threshold value is, right? And then whatever's going to happen in response to that. What this is making me think of is right now with my third through sixth graders, I've been playing around with the Hummingbird board.
Oh.
Now, the Hummingbird robot board is actually an Arduino Uno with a bunch of more kid-friendly connectors attached to it. With this one right now, I have a tricolor LED that you can program the color on that comes out of it. I've got a sound sensor. I've got a motor that actually goes across, I don't know if you can see it, on the front of my projector.
Okay.
Got a
bat signal
button because I'm working with a teaching coach who's trying to have me work on my signal. So as King of Snark, there was one day where I made a giant motorized signal so I could say my signal is on. But here's a word to the wise. If you create an interactive thing to keep your class quiet, it is not an interactive thing to keep your class quiet. It is an interactive game for your class to play to see who can make it go off. Right? Like I set the threshold and they set about finding it, right? And they weren't making a lot of loud noise. They were just chirping. They would go like, eh, and then it would go, and they'd be like, eh. Right? So it work to keep them quiet. But this was programmed in Scratch.
Okay.
So that was
really
kind of nice because ultimately you've got a sound sensor right here that you set a threshold for. And then there's an if-then block where it's like, if the sound sensor is above this, you're doing this. Otherwise, you're doing this. So
okay.
It was much more simple. And because you were working with Hummingbird and loading the Hummingbird library inside of Scratch, all of the kind of Python-based variables weren't in play. So with LilyPad, I know I'm struggling getting the right library loaded, getting the right firmware on the damn thing, and making sure that whatever other pieces I'm using are interacting with it correctly. There was also a really scary note about making sure you don't separate any of the pieces from any of the other pieces until you finish programming. I'm like, what? I don't think I had them all apart at that point, but it was nearly like, okay, guys. So, yeah, the LilyPad
there's an app that I found that I haven't been able to use called Cayenne that does block-based coding for Raspberry Pi, Arduino, and something else. My cat is playing with the cord right now, and it just lost everything. So I was going to see if I could. I don't know if I could do the LilyPad with it, or if it's just an Arduino. I just just downloaded it.
Depend on those libraries, right? Because that LilyPad hardware has whatever its library is,
and that's it.
Making sure that whatever coding programming environment you're working with it in has access to that right library. Okay. And I can say that authoritatively because I haven't made it work myself.
Okay.
I feel like you're getting the feel for our class and what's happening, and now what was happening in elementary school that you described, where the teacher has to be able to let go and of the knowledge and know that your students are going to go in all kinds of different directions, is what I try to recreate in this class. And honestly, it's easier to do with the little kids because they have no fear and they don't freak out when things don't work. And
they have are simpler, right? Essentially, the way that Cynthia is going to find the answer to her problem is digging through the forums on Instructables or harassing the people at SparkFun until they help her out personally. And that's...
I have to give a shout out to SparkFun because Cynthia did come across a barrier where she broke off one of the USB ports or something on your
the micro USB port.
And I wrote to SparkFun and showed them what her blog where she was documenting all her learning, and their answer was, we usually wouldn't do this, but my goodness, this documentation shows she's really a hacker and is really into this, and we're going to send her a new lily pad. So shout out to SparkFun for honoring your spirit.
Yeah, I tried to learn how to solder because I thought maybe I could figure out how to fix it. And then a friend of mine is an expert solderer and was like, yeah, no, you need this laundry list of equipment and you need these skills, and nice try, but no.
Onto a board, right? Like I solder, hold on. Right, tomorrow's crazy hat day, so I'm making up a little crown of LEDs, and I'm doing that, and I'm soldering the positive leads all to each other, and I feel super accomplished because I didn't actually break the wire. I just removed, switched some of the insulation and wrapped the LED around it and soldered it.
Right.
But wire-to-wire soldering and PCB board soldering, completely different things, right? Like when they actually solder things onto those boards, they put solder paste on them, and then they put the damn thing in a toaster oven that they put a voltage regulator on so they can jack it, they can overdrive the toaster oven, and they can melt all the solder in place.
He was saying something like you need some sort of water thing happening while you're soldering, like there's a water board for it. And I'm like,
yeah,
I'm not setting anything on fire. It's a win.
Right? Yeah, no, it's really, you know, I consider myself super capable if I have one of the little smoke eaters next to me as I'm soldering, so it picks up those horrible fumes and gets rid of them.
I had no idea that it was going to smell that bad either.
Yeah, that's molten lead, so, you know.
Who knew?
You might be using lead-free solder if, you know, bought it in a place that's brand new and is conscientious about that kind of thing. But, you know, that is something that when we work with the kids, we have to be mindful of. It has to be well ventilated. Soldering is something your school may or may not allow you to undertake with kids, but they're almost never going to be soldering directly onto a PCB board.
And you're right. I saw SparkFun build those when I toured SparkFun last month, and the whole pace and the machines, the PCB. Cynthia, you made a good choice there to let them replace it. Honor Sam's time. I want to see if Andrew and Nicholas have anything that they want to either ask or chime in before we leave. And I have one final question for Sam.
Sure thing.
And we
apparently Andrew doesn't.
Andrew left.
No, he can't.
Okay.
Pointing with his feet. Nothing to say. Okay.
All right, then I will. One final question I have for you is.
Oh, I think Nicholas had a question.
Yeah, no, I just wanted to say that this was very reassuring. This is my first year teaching technology courses. I was a former English teacher, so I had some technological background, but it's good to see other people succeed in a similar situation. So thank you.
And you took on some pretty challenging projects. Nicholas actually was one of my advanced learners who I had to really practice my walk the walk and about personalized learning, and just say, you want to go down that road? I can't help you, but go ahead, go for it.
Yeah. Found some fun stuff though.
Can you briefly tell us what your project was without going into a lot of details so that Sam knows what we're talking about?
Yeah, I was looking at learning some more like intermediate coding through some commercially available video games on Steam. So one was sort of like a microprocessor puzzler, sort of like a virtual Arduino called Shenzhen IO, which was really helpful for me in really problem solving and learning how to create different functions that accept inputs and outputs and have them all interact and work together for the desired outcome. So that was cool. The other one was Screep, which is a Java-based multiplayer strategy game where you write the code that commands what your units do. So in real time, you can just create a program and they'll just sort of run the program indefinitely and compete with other people through the online environment. And then the third one, which I haven't really gotten into yet, I'm not sure if I will for this project, was Else.Heartbreak, which is more of like a click-based adventure game, story-driven, but part of what appealed to me is that everything in the environment is hackable. So you can use a tool in this game, moving your avatar around and like change the street lamps color on like in the game. So it looked very interesting. I haven't delved into that yet. I'm planning on doing that this weekend. But look, it seemed to have,
I like it when we can give students tools that are completely hackable like that, because it just helps them understand so much better how constructed that world is.
Right. Yeah.
And so thank you, Nicholas, for sharing that project. Again, the environment I tried to create was similar to when I had my high school kids, and where they were all going in different directions, creating the school's first web server, doing things I had no idea how to do, which ended up to be why I ended up going to Marlborough to get my master's, because they had that type of environment and let us just go deep and very personalized. But one of the things that I found is that a lot of teachers, we are teaching the first generation of teachers who graduated from high stakes testing. And I think that we're asking them to do things that they haven't experienced, this type of learning that you're talking about, Sam. And I think that they're looking for the answer. They're looking to reach that content. They want you, they don't want to, they're afraid to take that kind of risk because of teacher accountability. And they're also not given the choice to sometimes pick how long they spend on a content area. So many of them are saying to me, it takes too long. I can't use Scratch to have kids write a story. That's going to take way too long. I don't have that type of give, and it's taken away from what I have to do in order to meet my requirements. Do you have any advice or any suggestions for our?
There's things that I've said as a teacher that I've said long before I use technology, right? If you're worried about covering curriculum, sit on the damn book. Wow, that's harsh, right? But no, seriously, like it's about focusing on the learning instead of the material to be learned. It's thinking about what are your actual goals for you and your student, and it's making the choices that, whatever you're able to make. Obviously, we don't all have total control over what we do in the classroom, but it's making the choices you need to make about what your kids are learning and how they're learning it. As an English teacher, if I were teaching high school English right now, I know that I would be asking my students to be doing more programming than I ever did before. I would be asking them to write incredibly short programs that didn't take that long. I would be giving them starter programs, asking them to make a few adjustments and turn them into me. I mean, I think it's that one of the mistakes that a lot of teachers think is that, oh, well, programming something takes a month. It doesn't, especially if you're reading The Outsiders, for example. Let's take a book that's really outdated. If you're reading The Outsiders because they just republished a 50th anniversary edition of it or something like that, you could take a Scratch program. All of your students, here's the assumptions. You're teaching The Outsiders. Your students all have access to at least a Chromebook. And you can give them a Scratch account. You've given them a Scratch account. You send them The Outsiders starter story. And you say, what I want you to do in the next 10 minutes is recreate the last scene from last night's reading. All you're doing is a comprehension check. Did they do the reading? They're going to create that scene, and you're going to be able to walk around and see actually in the first 2.5 minutes of this work if they've actually done it. and the rest of the time they're struggling to, you know, figure that out and turn it in. You've spent, you know, whatever it is, your 10 minutes tops, and you've done something that's a lot more engaging. Yeah, sorry, Cynthia. I know, right? But the good news is on the new version, if you get the new version and you tilt it back and forward, there's a golden holographic Stay Gold Pony Boy that shows up. So you gotta love that, right? But a lot of it's just about thinking differently about what you're doing in your classroom. You're not at, this isn't in addition to, this is instead of, right? Take those end of the chapter questions, throw them out the window. The kids were cheating on them anyway, and have the kids, you know, instead do a short video about this, do a short animation about that, you know, take The Outsiders and break it into 15 different scenes and give each kid a different scene, and then string it together like they do with the fan films for Star Wars and Empire Strikes Back, for example.
Well, Sam, you did not know how happy I am feeling right now. Just, you were amazing. And I know we took longer than we planned, but I just couldn't stop it. It was awesome. Thank you so much for being part of our grad school virtual field trip, and also a speaker, but also for Hour of Code. If you don't mind, if we just tweet this out at your, so other people can get your great advice.
Please do. Glad to share, always.
Thank you.
All right, see you all. And follow and tweet at me and ask me questions. I love helping people all the time, seriously.
And if I can help with that lily pad, that's actually one of my favorite tools, and I wanted to interject, but I didn't want to hijack this, so we'll talk about that.
Definitely, because one of my, I make puppets too, and one of my, yeah, puppetstelljokes.com, I'm desperate for subscribers. It's a new thing. I need support. But I really am intrigued with the idea of creating a puppet that is programmable. Not completely electronic, right? But something like, what could I do with that? It's something that I keep coming back to, and you know, this is really just, you know, one step away from being programmable. So yeah, it's always like what can I do next? And I always use my own hobbies and curiosity to kind of feed what we're doing next in class.
Thank you. I'll return this favor in the lily pad world. Bye.
Talk to you soon. Bye-bye.